Okay, hello everyone. Good evening. I'll be sharing my screen and one of you can quickly confirm if my screen share is visible. Accordingly, we'll get started. Yeah. Can someone please confirm if my
Y-
screen share is visible?
Hi, sir. Can see your screen. Thanks.
Thank you. Fine. Thank you for joining the day one class today. Let's get started with chapter one. So in chapter one, we are going to talk about the introduction towards API basics and also about the client and server architecture. Okay, so first thing first, we need to understand what exactly is an API and where exactly an API comes into role, typically when you take an enterprise application. So let me open a Word document and write the definition, and let me also diagrammatically explain my definition. So that way we can easily understand the definitions as well. So I hope the font size will be pretty much clear now. API stands for Application Programming Interface. I'm sure everyone is aware of it. Coming to the definition of an API, it is an interface that enables data transfer from one module to another module in a given enterprise software application. So it is an interface or component that enables data transfer across multiple modules in an enterprise software application. Okay, that's the simple definition of an API. But obviously, it is difficult for us to remember these kind of definitions, and sometimes they don't make sense also. But I'm going to make it easier for you, this definition. So I'll come back to the definition again. I'm opening Paint application, and I request you guys to visualize any e-commerce application. So example, I'll say this is my entire e-commerce application. And in this e-commerce application, let us assume the developer has developed four modules: module 1, module 2, module 3, and module 4. Okay. Let's restrict ourselves to four modules so that we can specifically talk about them. And coming to the application type, let's again assume it is our typical Amazon application. Okay. And let us call the first module as login module. And the last module is my logout module. And this will be add items to shopping cart. And this will be make payments. Okay, so these are the four modules that we have got in this particular application. And I'm sure everyone understands these four modules. Let us try to understand whether these modules that I have written here, are they independent of each other or they are dependent of each other. Let's try to understand that. So I feel login and logout are dependent modules because only if you log in, then only you can log out. Or only if you log out, then only you can log in. So I can say login and logout are dependent modules. Next, if I talk about make a payment module, in Amazon application, you cannot make a payment if you have not logged in. So make a payment is dependent on login module. Next thing is you can make a payment only when at least one item is present in the shopping cart, which means make a payment module is also dependent on shopping cart module. Right? That's something simple, everyone understands, right? I repeat, login and logout are dependent modules. Make a payment and login are dependent modules. Make a payment and add to shopping cart are also dependent modules because without one module, other module cannot do the work. Now, when there are two dependent modules, they need to talk to each other, right? Which means assume that there is a person called Kiran, which is me, and I have logged into Amazon. Then I went, had my dinner. I came back, I clicked on logout module. So when I click on logout module, what logout module does is it will make a function call to the login module. So it will make a function call to the login module, and it will ask the login module, is a person called Kiran logged in? If yes, is the session belonging to Kiran still valid or expired? So login module will say, I have to check my internal database to know if Kiran is logged in. And later it will give a response. The response could be, yes, Kiran is logged in, his session is valid. Or the response could be, Kiran is not yet logged in. Or the response could be, Kiran is logged in, but his session is expired. Accordingly, logout will behave, whether it has to log the user out or throw an error that please sign in to logout, something like that. So here, if you observe, the dependent modules login and logout are talking to each other. So what is happening? It is sending a request. And the login module is giving a response to logout module. So two modules are communicating with each other. They are exchanging data in the form of request and response. That is what this data transfer talks about across multiple modules. And those multiple modules are nothing but your login and logout module. And login and logout are present in an enterprise application, which is my Amazon application. Let me show one more example. Now, when I talk about make a payment, so Kiran clicks on make a payment, and make a payment has a dependency on login. So it will make a function call to login module. And the request is Kiran wanted to make a payment, but is he logged in? Login module says, well, I have to check my internal database and know if Kiran is logged in and his session is valid. After checking the database, make a payments will give a response back to login. Login will give a response back to make a payments. Assume that the answer is yes, Kiran is logged in. After that, it will make another function call to add items to shopping cart and says a person called Kiran who is logged in wanted to make a payment. But does he have at least one item in the shopping cart? Then shopping cart module uh, or add items to shopping cart will check internal database and it will give back a response back to make a payments. And the answer could be yes, he has two items in the shopping cart, or zero items in the shopping cart, or one item in the shopping cart, or four items in the shopping cart. Here also, if you have observed, there is a request going from one module to another module, and there is also a response coming in. Not only that, here also the modules are talking to each other. There is a response coming in, there is a request going in. So if you understand two modules are talking to each other by exchanging a request and response, all the modules are part of my entire Amazon.in application. That's why if you see here, enabling data transfer is nothing but sending request and response. Who are doing it? Multiple modules are doing it. Where are these modules present? They are present in an application called enterprise application, nothing but your software project. That's a fancy word for me to write. The question is, how can these modules talk to each other? You will say, Kiran, they are sending requests and receiving responses. Fine, they are communicating with each other using a request and response. But how is that even becoming possible? Okay, so the answer is they need a technology that can help in transferring the data from one module to another module, sending the request and response. Okay, so what is the technology that we have that is facilitating this kind of fantastic data transfer from one module to another module? The answer is API. So that is the technology available in the industry for logout module to communicate to login and for login module to communicate back to logout module. So if anyone says, what is an API? You can tell them diagrammatically this as the answer and this as the definition. Okay. And I will definitely go ahead and save all these things in my downloads. Save it as rough notes. Okay, quickly, let me figure out from you guys. Have you all understood the definition of an API and also the example I have given? So the definition is not by-hearted definition. It's something that we can easily frame on our own. Please let me know if it is clear or not. You can use chat or you can say, yes, it's clear. Or if it's unclear, put forward your question as well. But please acknowledge. I need to know whether it is clear or not for you guys.
I got it, Kiran. Thanks.
Perfect. Thank you. Please use the chat, guys, in case if you doesn't want to speak. Okay. Thank you, Subrat. Okay, cool. Okay. Now the second question is, now that the definition is clear, how are they able to communicate using API technology? But in which language they are communicating with each other? So that's something I need to answer. How am I communicating with you? English. Because we are human beings. We use different international languages, local languages to communicate with each other. For the training, English is the best suited language. So I'm communicating with you in English. You're also communicating back to me in English because we are human beings. But these APIs, these modules, they are not human beings to communicate in English, right? They are artificial entities on the computer, right? So how do they communicate with each other? So the answer is the extension of the definition. It is an interface component that enables data transfer across multiple modules in an enterprise application using descriptive languages such as HTML, XML, text, JSON, YAML, etc. So that's another extension of my definition. So whenever we talk about APIs, they simply send a request and receive the response between any two modules or between client and server. But when they're sending a request, it can take in any of these formats. When they're receiving a response also, it can take any of these formats. And I'm sure all of you are senior enough to know these formats. I'll quickly take 1 minute to explain it one more time. If you have any difficulty understanding the formats, it is your responsibility also to ask the question, right? Because I don't want to teach something which you already know. HTML stands for Hypertext Markup Language. It can be used to design web pages. It can also be used to transfer data between two modules. And HTML language typically uses tags such as arrow mark HTML, something like that. Something like this. They use tags like this. Okay. Then XML is also there, extensive markup language. It is also using the similar tag concept, but this is much better than HTML. Then we have text format, which is nothing but a plain text format or clear text format. It does not use any syntaxes or tags like HTML and XML. Then we have JSON. It stands for JavaScript Object Notation. It follows a key and value pair structure. Like example, if I have to give you, JSON is more important. I think that is an area where I can spend some time because even if you know, I have to insist it. And if you do not know, this will help you. It stands for JavaScript Object Notation. It is a way of transferring data from here to there, from there to here, client to server, server to client, module to module. It uses key value pair structure. The syntax of it is, it starts with a flower bracket. It ends with a flower bracket. And in between, you have a key, and every key has a value associated. If you have one more key and one more value, you have to separate with a comma and paste it. Like this, it will follow. If I have to write one example of that, again, I'll write two flower brackets. Right? So here I can say key is trainer name. Here. And participants count. Right now, I see 15 people as the count, including me. So let me say 14 as the count. So this is key. This is the value. That is what I said here. It follows a key and value pair structure. So this is a mechanism how people send data from one module to another module. JSON is mostly the preferred way that APS uses these days to transfer data from one module to another module. Just like English is famous, JSON is also equally famous to transfer the data. Okay. So if someone says what is an API, this is my explanation to them. And even in your interviews or while you're talking to your junior team or your seniors or developers, you have to be so clear like this so they understand what exactly is an API. Okay, so let us come back to my course content. So the first two things are pretty much clear now. This is what I have explained. It won't take much time. Now comes a major important topic, introduction to client and server architecture. So all of you are aware of what is a client and what is a server, right? Okay, let me see the chat. There is a message from Subrat. What is descriptive languages? Okay, good question. So we have front-end programming languages, back-end development languages, right? Similarly, the word descriptive languages are used whenever the language is used to transfer data. Okay, so when one module is talking to another module, it is sending in a particular format, which is HTML format or XML format or JSON format. Now, these languages, HTML or XML or JSON, they are not used to develop a software. To develop software, you have programming languages. In the software, two modules want to talk to each other. So they also, you have to use some language. That language, we call it as descriptive languages to transfer the data. Am I clear, Subrat, here? Okay, perfect. Thank you. So we're talking about client and server architecture. Can anyone help me understand what is a client and what is a server? And examples of client and examples of server. Anyone who can take up that question and answer, what is a client and give me an example? What is a server? Give me an example. Okay, let me answer it then. A client is any, okay, I see a chat. Client is browser, which sends a request. Answer from Sai. That's perfectly correct answer. Thank you. Just 1 second. Okay. So client is any application or a device that submits a request to the server. So let me write here, client and server architecture. That is the discussion we are doing. A client is any application or device that sends request to the server. And coming to server, a server is any application or device that receives client request to analyze it, plus process it, plus give a response to the client. This is a simple definition of client and server that we have. And I'm sure everyone is aware of it, but it's just a Q&A session that I wanted to have with you guys. Now, the question is examples of client. Okay, I see some answers from Sai and Laiku. They're all correct. Thank you. So example of a client is browser. Everyone uses browser, right? We use browser to send a request every day. Like I type gmail.com, you type outlook.com, instagram.com, web.whatsapp.com. So whatever request you type on your browser, that is the request you're initiating from browser, which is a client to the server. The server could be Gmail server or WhatsApp server or Instagram server or YouTube server, whatever it is. So browser is one of the famous examples for client, and that's the world's favorite client also. In this course, I'm teaching you a tool called Postman. Postman is also an example of a client. Okay, so your REST assured tool is also a client. Selenium tool is also a client. Appium tool is also a client. Jmeter is also a client. LoadRunner is also a client. Everyone is a client. Now we need to understand example of servers. So example of servers, we have infrastructure servers and we have application servers. So you might have heard of application servers, web servers like Apache Tomcat. That's one example of application server or web server. Then Nginx is there. Then you might have heard of Microsoft IIS, Internet Information Service. Then you have IBM WebSphere. That's another application server we have. Then you have Glassfish, which is another application server that we have. So these are examples of application servers. But apart from application servers, we also have infrastructure hardware servers, which are sponsored by AWS, Microsoft Azure, Google Cloud Platform, GCP. So these are examples of infrastructure servers. Okay. So now we know what is a client, we know what is a server, and examples of client, examples of server. What am I going to teach is client and server architecture. Like how do they communicate with each other? Right? That is what I'm going to explain. And if you say, why am I explaining it? This is necessary to do API testing as well. Okay. So the job of a client is to send a request. So this guy is sending a request to the server. And the job of server is to give back a response back to the client. So this guy is also giving a response. But we need to discuss the lot of other things between client and server architecture. That's what I'm going to discuss in the rest of the class. And I have a question from Sai on the chat. I have sometimes confused with web server and application server. All APIs will request web server or application servers. Okay, let me answer this question, Sai. So, first of all, web server and application servers are different. Okay. An application server, if hosted on the internet, it becomes a web server. If that application server is not yet hosted on the internet, but it is there only in a local area network between a client and server, then we use the word application server. Okay. If it is on the internet, we call it as web server. If it is not on the internet, if it is only within the network of computers but not on the internet layer, we call it application server. But today everyone uses internet only. There is no concept of only client and server, right? We have the internet layer also. So the word web server is right to use today. Application server is an old word to use. That is first differentiation. Then coming to the question, second part of your question, all APIs will request web servers or application servers. So the answer is web servers. Okay. APIs will request and talk to web servers only. But in the industry, people interchangeably use the words as application server or web server. So even if I use the word application server, I mean web server. Even if a developer uses the word application server, he really means it as web server only because they exchange the terminologies and they often create confusion to people. I hope that answers your question. So coming to the client and server architecture, we agreed that the client sends a request to the server, right? This guy sends a request to the server. Okay. And we know that the server also gives back a response from the server to the client. But we need to know some examples of request so that we know it is exactly a request. So request can be anything. Example, I'll type some application URL that I'm aware of. Don't worry of what I am typing. That's just a request. On the browser, I have typed my request. So this is the request I have executed on the browser. I'm copying it. So that's one example of a request I have. Okay. And you also see that we got some response from the server. And this is typically in the key and value pair structure, which means it is a JSON response that we have got from the server. So if I come here, yes, we got the response in JSON format. Perfect. Let me change the example. I'm typing another request on the browser, as you can see. And this is the request I have sent on my browser. The request went to the respective server, which is http://bin.org. And if you see here, the response I got is an XML response that you can clearly see on the screen. So this time, the request changed and we got a XML response. Next, let me type something else called another request. And this time the response will come in HTML format. once the page loading is completed. See. So this is another request I have submitted from the browser. And I did receive the response on the browser. This time it is in HTML format. Okay. If you say, Kiran, how do you know it is HTML format? I mean, I assume you know it, but otherwise, if I right click page source, I can see HTML syntax coming up. That's one way. Then let me type one more example. That's another request I'm typing. And this time also we got response. This time it is in text format. So this is the request I have sent to the server. And this time I got the response in text format. So if you have observed, each time when I send a request, I'm certainly getting a response. The response type is different each time as I send the request, which means these servers are capable of sending responses in any format. Sometimes they send in JSON, sometimes XML, sometimes text, sometimes HTML. So based on the request, the response varies. Okay. Am I clear until this point on what is the request, what is the response, examples of client, examples of server? Please give me a confirmation if I'm clear until this point, yes or no. Guys, I'm waiting for an acknowledgement. Have you understood until this point?
Yes.
Perfect. Thank you. Okay. So the next thing that we should know is what else the client sends to the server when the request is going. The next thing we should know is client sends a protocol as well along with request. Every request has something called protocol associated with it. Now coming to protocol and the definition of it, I'm sure you guys are aware of it. So a protocol is a set of rules or guidelines that abides how client and server shall communicate with each other. Okay. So protocol sets a lot of rules, guidelines, standards, procedures between client and server so that when the client sends a request, the protocol tells the server that receive it and give back a response to client. And the same protocol tells the client that you receive the response when server is sending it to you. So it acts as a coordinator between client and server just to ensure that server will listen to the client question and client will listen to the server answer. And in the industry, there are so many protocols available. Like if I have to name few, we have HTTP, HTTPS, FTP, SFTP, IMAP, SMTP, POP3, LDAP, JMS, GraphQL, file protocol, JDBC protocol, SQL protocol, etc. There are so many protocols. I was able to tell at least 13 now, right? Now in API testing, we don't want to learn all these things. There are two protocols that you should know. One is HTTP, the other is HTTPS. I'm sure you're aware of HTTP, HTTPS, but it is my job now to explain it one more time and give you one new information in this class. HTTP stands for Hypertext Transfer Protocol. This protocol is designed in Web 1.0 era, which means it was designed or developed in 1980s, late 1980s or beginnings of early 1990s. That's the era which is called Web 1.0. And when HTTP protocol was designed, internet is completely new, very, very new to most of us, right? And this protocol, HTTP, is an unsecured protocol by design. By design, it is unsecured, which means whatever data we are transferring from client to server in this diagram, the hacker can come in between and can steal the data. Example, this client is sending a request called my password is Kiran123. So what happens? This message will be traveling when you click on login button to the server like this. But in between, there is a hacker. Okay, so in between I have this hacker, and what this hacker does is he will steal the data. And he can see the password as it is as Kiran123 because client is using old HTTP protocol. HTTP protocol transfers the data in the same text format. It won't convert it into encrypted format or encoded format. No secrets. It is sent as it is. So hacker can see your password and he can probably compromise your emails, your system access, everything. He can compromise it, right? Now, knowing this problem, why did the industry created HTTP protocol as unsecured protocol? Simple. When when internet evolved in the beginning of 90s, there is no concept called hackers. There is no concept called social media. There is no concept called online payments. There is no concept called login, first of all. So internet was like a digital newspaper. People come, they open some website, read the content, that's it. The job is done. So it was like a digital newspaper where security is not important because you are not logging in, you're not commenting, you're not liking it, you're not sharing it, you're not doing live streaming, you are not doing payments, you're not doing anything, just coming, opening, reading the content, and shutting down the computer. So there is no need for security in those days. That's why HTTP protocol is by default unsecured protocol by design, and it transfers client request or server response in plain, clear text format. Okay, that is about HTTP. And typically, we do not recommend anyone to use HTTP protocol today when you are testing APIs because you cannot risk your customer data by using old, outdated protocol HTTP. Okay, am I clear, everyone, on HTTP? Perfect. Then slowly towards the end of 1990 era, which is like the beginning of 2000 or closure of 1999, 1990s, the concept of email came into picture. Coolmail.com has come, Hotmail.com has come, Yahoo Messenger became a phenomenon where people used to chat with unknown people, do webcamming, etc., etc. So then the industry realized we need to have security in place because people are logging in to send electronic emails, to chat with someone. Their personal data is there. So they came up with HTTPS. So HTTPS is Hypertext Transfer Protocol with the security added to it. It is not a second protocol. It is the same old HTTP protocol with just the concept of security coming into picture. And when this came into picture, we call it as Web 2.0 era. Beginning of 2000 is called 2.0 era. And this protocol is secured protocol by design. Why it is secured? Because what HTTPS does is it transfers the data from client to server in an encoded format or encrypted format. Example, I'm logging in with the username as Kiran and the password is Kiran123. Now, when this data is going to the server, on the way the hacker comes and he wants to steal the data. So let me say this guy is our dangerous hacker and he wants to see what is there here. The moment he takes the control, he will see username as something like this and the password as something like this. So this is not at all understandable to hacker also. This is all junk data that he is seeing it. So he cannot log in with this username and password because original Kiran has become like this. Original Kiran123 password has become like this for a hacker because it is transferred or it is converted to some other format which a hacker cannot understand. That is called as encoding or encryption, depending on what our developer is using it. So here I will say, maybe I can copy this to save time. It transfers the client request or server response in encrypted format. So encrypted format is a format which only client and server can understand. No one else can understand it. Server can decrypt it once it receives the encrypted format. Okay. The question is, how did HTTP become HTTPS? Is it just by adding the letter S it became secured? No. HTTPS uses cryptographic protocols such as SSL or TLS to encrypt the client request or server response during client and server interaction, which means when the normal HTTP protocol is given the power of SSL cryptographic protocol, HTTPS comes into picture, or when the normal HTTP protocol given the power of TLS cryptographic protocol, HTTPS comes into picture. This is how HTTPS is created. And today, as we speak, HTTP plus SSL is an outdated concept. And the latest concept is HTTP plus TLS, which is HTTPS. Now, within TLS, we have different versions. Version 1.0. Then we have TLS version 1.1. Then TLS version 1.2. Then TLS version 1.3. So TLS 1.0 is outdated as of today. All these are outdated as of today. And TLS version 1.3 is latest as of today, which means when you are testing your APIs, these becomes your test cases. Ensure the developer does not use SSL. Ensure he uses TLS. Ensure he does not use 1.0, 1.1, 1.2 TLS. Ensure the developer uses 1.3 version of TLS only to protect your API request and API response coming from server or going from client to server. So in my diagram, client and server architecture, I would say HTTP unsecured, HTTPS secured, and we have to recommend the developer to use TLS version 1.3. So these are our test cases. So what are our test cases? Ensure the developer does not developer, ensure the API does not use HTTP, right? So maybe here I can say, verify if API request does not use HTTP. That is one test case. Verify if API request uses HTTPS. Then verify if API request does not use SSL cryptographic protocol. Verify if API request uses TLS version 1.3 cryptographic protocol. Then verify if API request does not uses TLS 1.0 to TLS version 1.2 cryptographic protocol because they are outdated protocols. Outdated means they can still be used by hackers to decrypt the data. But TLS 1.3 is latest as of today. Hackers cannot use it to decrypt your data. Okay, Satish says what is SSL and TLS? I think I've explained it here. It uses cryptographic protocols called SSL or TLS. And if your question is what is the full form, SSL stands for Secure Socket Layer. TLS stands for Transport Layer Security. These are cryptographic protocols that convert to plain text into encrypted format or encoding format. Okay, it is that magic which takes the plain text and converts them into encrypted text. So HTTP protocol uses these cryptographic protocols to protect your data during encryption algorithms. We always hear encryption, right? In WhatsApp also you see encryption, your messages are encrypted. How? They use these cryptographic protocols. Okay, now your question is what is cryptographic? Now, cryptographic, again, is a very complex word to explain. I would say cryptography is the process of securing your data while transferring from one system to another system. Simple example is, let's say, I will ask my kid, come here. He comes, I give him 100 rupees. I tell him, go and hand over this 100 rupees to your mom. My kid happily runs, plays with 100 rupees and starts walking from current room where I'm teaching you until the kitchen where my wife is cooking food for us. On the way, my younger kid will pass through hall where his brother is there. Now, brother can see the 100 rupee note because my younger kid is just playing around with it. So my elder kid can say, hey, why are you playing with money? You're not supposed to do that. Hand over that money to me. I'll give it to dad or mom. What happened? My elder kid is behaving like a hacker here and he might steal the data. Because my younger kid is exposing it to everyone. That is plain text. My younger kid comes to me and says, Dad, I'm sorry, brother took that money. I said, take it, chalo, it's okay. I'll give him another 100 rupees. And I'll tell him, keep it in the pocket and then go and give it to your mom. Now, my younger kid, when he passes from the current room until kitchen, his money is protected in the pocket. My dad cannot see, his brother cannot see, my mom cannot see. Only when my younger kid reaches destination, which is a server, he opens the 100 rupee note and hands over to his mom, which is a server. So in this process, my data is protected. My 100 rupees is protected using pocket. So that process of protecting your money in the pocket is nothing but cryptography. So what is cryptography? Protecting your data while transferring it from one place to another place, which could be between client and server or between two modules. Okay, that's a simple way of explaining it, but there are better ways to explain it, but we can always Google it to get better definitions. Okay, so this is about the protocol part of it, and we have written some test cases around it. I'm sure everyone is following me. If not, please ask for questions on the chat or unmute. The third thing that client and server talk to each other is called HTTP methods. We also call them as HTTP verbs. I'm sure everyone has heard of HTTP methods and verbs. And the moment I say it, people say it is nothing but get, post, put, patch, delete, etc. They're all examples of HTTP methods. But if I have to define a HTTP method, this is how I would do that. Okay. Yeah. So HTTP methods or HTTP verbs. I will say it describes the type of client request be sent to server. So if you look at the diagram, what is client doing? It is sending a request. So server can always tell the client, what are you sending to me? Client says request, but what type of request you are sending to me? So to answer that question, we use HTTP methods. Now you might have the question, do we also have category of request? The answer is yes, right? If I ask one of you for a favor, right? Example, I'll take someone's name, let's say Ravi. So I'll say, hey, Ravi, I need some favor from you. Now Ravi can say, what type of favor, Kiran? The favor could be, I need money, that is financial help. I'll ask him, can you take the attendance of all the participants and email it to me? That's another favor. Another thing is I'll ask him, why don't you enroll in my course? That's another favor. I'll ask him, I have given you the notes, please forward to everyone. That's another notes. Sorry, that's another request. So when I say between two human beings also when they request each other, there is a category of request that we do. It could be knowledge related, it could be money related, it could be document related, it could be a physical activity that is needed, like running, jogging, etc. Right? Similarly, when client and server are talking to each other, client sends a request, and that request also has a category that is described by HTTP methods. So what is HTTP method? It describes the type of client request we are sending to server. To describe it, we use methods like get, post, put, patch, delete, and etc. There are so many other methods, but these 5 methods are important for us to know. When we talk about get method, get method is used when the client requests the server, give me the data which is there in your database. Meaning, you already have the data in the database, give me that existing data. If that is the favor client wants, it uses a HTTP method called get. So server knows that the moment it sees the request as get, Server knows that client is asking me something which I already have in my database. Something like, I'm feeling thirsty when I'm teaching you guys because I'm talking continuously. I'll ask my kid, get me a glass of water. Now, I'm asking something to my kid, and that something is water which is already present in my home, meaning it is there in the kitchen. So I'm asking him something which is there, which exists in the kitchen. So that example of asking him, give me a glass of water, is actually a GET request only. Okay. So what is GET? It is used to fetch or read or retrieve the existing data from the server or from the database. And to make it more easy for you, it is similar to select query in RDBMS. In relational database management systems, you have select a query, right? Select star from table. It will give you everything that is present. Okay, that is get method for you. Examples of get method will be browsing any website, browsing a web page. Example, I type Isha Training Solutions.org. That's a get request because I'm asking server, give me the content of Isha Training website, and it's already present on the server. Then file download. If I'm downloading a file from the internet, it is also a GET request because I'm downloading a file which is already there. It's a GET request. Opening an email or a message because the email is already there, the message is already there, you're opening it. It's an example of GET request. Okay, that's about GET. Next, POST request. POST means when the client tells the server, can you create this in your database because you don't have it. In such type of request, we'll use the method as POST. So it is used to create new data or new resource or new object on the server or on the database. To make it more easier, it is like your insert query in RDBMS, relational database management systems, like insert query used to insert data in the database. That is at the database level. At the backend layer, we use POST method. Example, my kid brought me the glass of water, which is GET request, but I'm not happy with it. I'm still feeling thirsty. So I'll call my wife and tell her, if you don't mind, can you prepare apple milkshake for me and bring it to me? Now, apple milkshake does not exist in the kitchen, right? Not in my kitchen, nor in your kitchen. The one in the kitchen has to prepare it. They have to chop the apples, put it in the mixie or grinder, pour some milk, put some sugar, stir it well, put it on the glass, and then bring it back. So they have to prepare the juice, meaning they are creating the juice in the kitchen, which does not exist earlier. So asking someone to prepare apple milkshake is an example of POST method. Okay? Technical examples if you want, when I upload a file uploaded to a server is an example of POST method. Because when you upload the file, you are also creating the file on the server. Sending an email or sending a message to someone else is an example of POST method. When user does a sign up or registration process on any other website, they're all examples of POST methods. Because when you sign up, you're creating your user account. And whenever you make an order on e-commerce application or on your food ordering applications, like in India, we heavily use Swiggy, Zomato to order food, right? Maybe now you're feeling hungry or I'm feeling hungry. I open Swiggy and then say, okay, book one biryani to me. Order made. So I created an order for that restaurant using Swiggy or Zomato app. Or you're purchasing something online, like you're purchasing an Android phone, iPhone, or groceries. When the order is created, you are creating a new entry in the database. Such actions on the internet uses POST as the HTTP method. Okay, I have a question from Laiku. Please go ahead.
Hi, Kiran. So Okay, when you say it's like insert query, are we, is the data getting saved at the same location within the same tables when we are posting as well as when we are inserting data?
Yes, obviously same.
Yeah, okay. So we really are just posting data into the database instead of using insert query, we are just using post method from right?
Yes, that's right.
So all the data
So
still exists in these database tables at the
yes,
end
the
of the day,
data.
back end.
Yes. So let me show that to you. So
Why I was a little confused was when you said you're going to be only using APIs for web applications, right? Um,
mm,
I think for uh, the legacy applications which are desktop driven, right? Installed on the desktops, we still have APIs, right? Talking to each other within the modules, or no? Or is it just purely a database?
okay, so when we say an application, it can be accessed on the mobile app, it can be accessed on the browser, or it can be accessed directly on the desktop as an application. Second question is, do we have APIs only on the mobile app, or only on the browser, or only on the desktop application? The answer is APIs exist everywhere, whether it is desktop or web application or mobile app. APIs exist everywhere. The only condition is if your application is talking to server over the internet, then API exists. If the application is not talking to internet and the server, APIs do not exist. Like,
Example SAP, right? It's a client server. You're installing it, and then you have data, and the client is talking to the server. It technically does not. It's not a web application,
correct, it's a desktop
so
interface.
it still is going to use the APIs.
Yes. So the answer is yes. But the question I have to you is, can you work with that SAP application without internet?
No, yeah. I mean, oh, so you're saying that, okay, I think I got it. Because I was just thinking it's only when you're using HTTPS URL when it becomes a web application, and only when that application has, APIs talking to each other.
Perfect.
But I
So,
get it. Yeah, it's www, not HTTP as such.
yeah. So simple. So this is a question that even I had in the initial days of my career. And there is always a confusion, as we work with so many technologies. So APIs exist in all these three applications, whether it's a desktop or web or mobile. But the catch is it should be talking over the internet. If I say I developed an application and it does not need internet, I will say you don't even need APIs in that case. If I say I developed an application, it needs internet, then definitely you need APIs also. Because APIs help client and server to talk to each other. And client and server can talk to each other only over the internet. When we talk about current technology, current era, right? If you're talking about 1990s, 2000 year, then client and server means only one client, only one server. They are present in the same room. All they need to talk to each other is one physical wire. But today, client is my computer, which is in Hyderabad. Server is somewhere in AWS, which could be in Singapore or Mumbai or could be in United States. I cannot draw a wire from my Hyderabad to US. So we need that internet layer under the sea to communicate with each other. That is where APIs comes into picture.
Yeah, got it.
Okay.
Yeah, I was really thinking about point of sale applications which are standalone sometimes. They probably wouldn't really need this whole architecture. It's not that complicated, I guess. But yeah,
Yes.
that
Yes.
era is gone. All right. Thanks, Kiran.
Perfect. Okay, cool. So we're talking about post method. Post is a method used by client to tell the server that I am sending a request and this request will create new objects on your database. And what kind of request you do on the client? File upload. That uses post method because you're creating file on the server when you upload. Like when you upload photos to Google Photos, every photo you upload to Google Photos is a post request. And you upload your resume to naukri.com or any recruitment portal, that is also a post method. And if you're sending a mail or a message on WhatsApp, it uses post method because you're creating data with that step. Whenever you make an online payments, complete an order, create an order, it uses post method. When you sign up to any abcd.com website, it uses post as a method because your account is getting created. Okay. I'll complete the remaining three and then we'll do a sign off for today. Okay. Is someone having questions to me? Okay, I'll mute. Okay, put method, patch method, and delete method. Now, put and patch are almost the same with some differences between them. Put is used to update data in the database. So it is used to update or modify or replace existing data in the server or in the database. It is like update query in RDBMS. Examples again, if you want, for put method, change password. Whenever you change password in your Gmail Outlook, you are replacing old password with a new password. That's nothing but put request. Or whenever you update profile settings, or whenever you update your WhatsApp display picture. Okay? We update photos on WhatsApp or social media like Instagram, Facebook, etc. Right? So you are changing old picture to a new picture. And sometimes you edit your sent messages. Like in WhatsApp, we do, right? Maybe there is a spelling mistake in the message you sent and you will edit it and correct the spelling. So any action that you do on the internet, which is editing your old data and replacing with new data, please note you are doing a put action from client to server. Same definition holds good even for patch method. Then you might say, then what is the difference between these two? Why the industry created two methods when the definition is same? There is simple difference. Input, I can update all the fields in the database. Whereas patch, I can update only few fields in the database. So here, when I say existing data, it is partial or selective data. If there are 10 fields in the database that I can update, patch can be used to update less than 10 fields. Meaning, if I'm updating 5 fields in my database, because my form has only 5 fields, like first name, last name, gender, date of birth, and email address. If I'm updating all the fields, I can use put method. If I'm updating less than those 5 fields, we can use patch method. So put can be used to update full data or partial data as well. Put can work like patch also, but patch cannot work like put. So between these two, put is much better because it can do even patch work. Patch cannot do put work. So put and patch are used to update your data in the database. Finally, delete method, self-explanatory. It is used to delete existing data in the server or in the database. Again, it is like delete query in relational database management systems. And example, if I have to talk about deleting emails or messages, then deactivating social media accounts, cancel your order that you placed using post method in Amazon. All these are examples of your delete methods. Now, whenever you are sending a request from client to server during API testing, you will come up with these HTTP methods. So you have get method, post method, put method, patch method, delete method. Every API request is associated with these HTTP methods. And these HTTP methods are referred as CRUD operations testing. C stands for create, R, D. R stands for read or retrieve, U stands for update, D stands for delete. So for create, we use post method. For retrieve, we use get method. For update, we use put or patch methods. For delete, we use delete methods. So CRUD operations testing is something that you often hear in API testing language. CRUD is nothing but these HTTP methods usage. So we have so far discussed around 45 to 50% of, not 50, maybe 40% of client and server architecture. We'll continue our conversation tomorrow and complete the entire client and server architecture. So to ensure that I don't lose the data, I will save it on my computer. Before we sign off, if there are any questions to me, you can ask us. You can ask me.
Kiran, quick question. So from an architecture standpoint, how would we know if the client is actually using SQL to do these actions versus the methods?
Okay, so I'll give a detailed answer in the upcoming classes, but for now, to give an answer, your client is typically the browser, which is running on front end, right? It is either a browser or a mobile app, which is like a button on the form that you are clicking on it. Example, the button is register button. You are filling the form and clicking on sign up button. That sign up button will call the backend layer. This is where your API call is there, where that post method is coming into picture. Then that API will call the database server. And the server has the database layer. In the database layer, the insert query is called internally. So this is the structure it follows.
Okay, got it. Yeah, that's the one that's the one I wanted to be clear about because it's a bit confusing sometimes as to why we're using APIs versus, just inserting queries into the database.
Perfect. Cool. Yeah, I will talk about this topic again in chapter 1 when I'm talking about three-layer architecture. Okay, cool guys. So that's about our day 1 of training. Tomorrow we'll complete client and server architecture. And if time permits, we'll also talk about three-tier architecture model. Otherwise, we'll just stick to client and server architecture discussion for tomorrow. I hope you guys were able to follow me. If you have any questions, feel free to ask me on the WhatsApp as well, or you can ask me tomorrow. Thank you for being patient in today's class. I'll see you guys again in tomorrow's class. And as usual, if you are happy with the way the training is going on and this is what you're looking at, talk to Isha team and complete your enrollments. Thank you very much. Good night. And how do you get the notes? Once the participants list is confirmed, only then the notes will be shared with you. But this rough notes, whatever I'm doing, if this is something that you're asking for, I can just put it on the WhatsApp chat as well. But once the enrollments are done, the answer will be Google Drive. Okay, I'll do that. Fine, guys. Thank you very much. Good night. Stay safe. Take care. See you tomorrow. Bye bye.
Thank you. Bye bye.